Classes. C++, the basics. Having the data specified separately from the operations on it has advantages, such as the ability to use the data in arbitrary ways. However, a tighter connection between the representation and the operations is needed for a user-defined type to have all the properties expected of a real type. In particular, we often want to keep the representation inaccessible to users, so as to ease use, guarantee consistent use of the data, and allow us to later improve the representation. To do that, we have to distinguish between the interface to a type to be used by all and its implementation which has access to the otherwise inaccessible data. The language mechanism for that is called a class. A class is defined to have a set of members, which can be data, function, or type members. The interface is defined by the public members of a class, and private members are accessible only through that interface. For example, class vector, public. Vector int s, elem new double array of s, szs, construct a vector. Double and operator, int I, return elem array of I, element access, subscripting. Int size, return sz. Private. Double asterisk operator elem, pointer to the elements. Int sz, the number of elements. Given that, we can define a variable of our new type vector. Vector v of 6, a vector with 6 elements. We can illustrate a vector object graphically. Basically, the vector object is a handle containing a pointer to the elements elem plus the number of elements sz. The number of elements 6 in the example can vary from vector object to vector object, and a vector object can have a different number of elements at different times. However, the vector object itself is always the same size. This is the basic technique for handling varying amounts of information in C++, a fixed size handle referring to a variable amount of data elsewhere, example, on the free store allocated by new. Here, the representation of a vector, the members elem and sz, is accessible only through the interface provided by the public members, vector, operator, and size. The read and sum example simplifies to double read and sum, int s. Vector v of s, make a vector of s elements. 4, int I equals 0, I not equal to v dot size, plus I. Cin, v array of I, read into elements. Double sum equals 0. 4, int I equals 0, I not equal, v dot size, plus I. Sum plus equals v array of I, take the sum of the elements. Return sum. A function with the same name as its class is called a constructor, that is, a function used to construct objects of a class. So, the constructor, vector, replaces vector init. Unlike an ordinary function, a constructor is guaranteed to be used to initialize objects of its class. Thus, defining a constructor eliminates the problem of uninitialized variables for a class. Vector, int, defines how objects of type vector are constructed. In particular, it states that it needs an integer to do that. That integer is used as the number of elements. The constructor initializes the vector members using a member initializer list. Elem, new double array of s, sz of s. That is, we first initialize elem with a pointer to s elements of type double obtained from the free store. Then, we initialize sz to s. Access to elements is provided by a subscript function, called operator. It returns a reference to the appropriate element, a double and. The size function is supplied to give users the number of elements. Obviously, error handling is completely missing, but we'll return to that. Similarly, we did not provide a mechanism to give back the array of doubles acquired by new. Next lessons shows how to use a destructor to elegantly do that. Thanks for watching.